All right, this is 4-5 systems of linear inequalities. And the last section we started graphing linear inequalities and shading one side of the line. Make sure you know how to do that lesson before watching this and knowing how to do this, because now we're going to be talking about a system. A system is more than one. And so what we're going to do is focus on learning how to graph them and then shading them. So if you remember, like if we just had an equal sign, like a system of equations, we had an equal sign, we would graph the red, graph the blue, and then find the one point of intersection. Okay, that's what we would look for, is find the point of intersection. But this isn't just one point, because what we're interested in is all of the points. Like on the red, we want all of the points that are greater than that expression. So what we're going to do is you graph it as if it said y equals. So just pretend for a moment that it says equal, and then you graph it like -2, and then you're going to go up 1 over 1, up 1 over 1, and then you just graph it. And again, just for time's sake, I'm not going to get my ruler out and draw, like a perfect line. So I'm just going to freehand it. Okay, actually, let me back that up. I happen to notice it is equal to, and normally we connect the dots, but remember this is just, it does not have an equal sign with it, so it's just going to be hyphenated. It's not a solid line. It does not include any of these points on here on the line would actually not work. Okay, that's what the dotted line mean, or the slash line. It means the line, any point actually on that line does not work in the equation. So that's what that means, and it says greater than that, so we would shade the side that's greater. We talked about that in the last lesson. There's several ways to find that, and to do that, you can always just choose a number, just randomly choose a number like 0, 0, and see if that side of the line works. So if the point 0, 0 works, so I'm going to plug 0 in for x, and then 0 in for y, and that's going to give us 0 is greater than -2, which is true. That is a true statement. So this point works, and so everything on this side of the line would actually be shaded. So that's really what that's talking about, and then we would just shade everything on that side of the line. Now that's the red line. Now the blue line, again, we did this last section, so we would do the exact same thing. We would pretend just for a moment that it said equal, and we would graph, we're going to start at +1 and then down 1 over 1, down 1 over 1, and then we're going to get our line going. And this does have an equal sign with it. So this is actually going to be a solid line. And then it says less than. So again, we would shade the side that's less than that line. And again, if you're not 100% sure which side is less than, you could just pick some random point that's not on the line. So again, I'm going to choose 0, 0 again. Again, you don't have to choose 0, 0, but it is a nice, easy number to pick. And I'm going to choose, as long as it's not on the line, and I'm going to put 0, 0, and see if that's a true statement. Yes, it is. That's a true statement. So that side of the line does work, which means everything over here would actually work. And then we're going to shade all of those in that side, and let's just shade it purple. Now, on this problem, you don't have to draw two graphs. What we're looking for is a system. So what are the points that these both have in common? So if we graph the red line, that's what this third one is for. I just wanted to graph them individually to show you what they would look like individually. So what we're going to really do is graph them both on the same, we're going to graph the red line and the blue line on the same graph, and then shade them together, and then whichever area has the double shade is my true area. So I went ahead and graphed the red line. Notice the red line is dotted and the blue line is solid. And then if I shade the red line, remember the red line is everything in this direction. So if I shade everything on that side of the red line, And then remember the blue line has a shade of purple on this below the line. And notice the one section that's actually shaded, double shaded, is this section in here. This section is the shaded area that we're interested in, because we're trying to find the point. And what does this mean? That means this point, any point in this section, works on both the red and the blue the inequalities. So you can always check this too, like literally pick a point, just random point, and see if it works on the red and see if it works on the blue. And that's what this double shaded area in here, this shaded area in here, every point in that section will work on this inequality and will work on this inequality. If you pick a point, like let's say you pick a point over here, it will work on the red line, the red inequality, but it would not work on the blue. If you picked a point down here, it would work on the blue, but it would not work on the red. If you picked a point over in this section, it wouldn't work on either one of those inequalities. So you're trying to find the area that works on both inequalities to be able to do that. All right, so let's look at another one. Again, you have a red line and a blue line, and we're going to graph them. Notice the red line is solid on this problem, and the blue one is a dotted line. So we're going to go ahead and graph those. And the red one, it says it's a solid starting at 2, and we're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay, and that's a solid line. And notice this says it's greater than that. So again, think of shading everything greater than that red line, and where is it going to be shaded at? And so if you're not sure, you can always pick a point. Something, if you want to choose 0, 0, that's fine. Pick 0, 0, and put 0 in for x, 0 in for y, and see if that's a true statement. 0 is greater than 2. That's a false statement. So that side of the line does not work. So what we need to do is we're going to shade the other side of the line. So we're going to shade this side of the line. So every point over here would work on the red, okay, would work on the red inequality. Now let's graph the blue. So if you graph the blue, you're going to start at -2, and it has a negative slope. And this is a dotted line, so it's hyphenated. And notice what this says. It says it's less than. So again, you shade all the section that's less than the blue. And, again, if you're not sure, you can always just pick some random point, like 0, 0 again. So if we put 0 in for y and 0 in for x, we're going to get 0 is less than -2, which is false statement again. So the other side of this line will work. So let me get my highlighter out. So this side of the blue line will be shaded. So again, what this means is anything that is shaded will work, because that's what I'm looking for. That will work on the entire section. So any point over here is going to work on the red. Anything over here is going to work on the blue, and that's the areas that I'm looking for. Which, by the way, just as a side comment, since these shades don't overlap, that means there's no point in common that will actually work on all of the both inequalities, both the red and the blue. There's no point that will actually work on both inequalities. But again, we're shading in all the possible points that will work on the red and all the possible points that will work on the blue. All right, this is the exact same problem, but I want you to notice I did change the inequality. So how is that going to affect the graph? So again, it's the same exact actual equations, except I changed the actual inequalities. So notice I want everything on the red, I want everything less than the red, but I also want everything greater than the blue. So what's actually common, everything less than the red, if you shaded everything less than the red, so it would literally be all of this, everything below the red, and if you shaded everything above the blue, it would look like this. And what is the common area that's shaded? Notice what's in between is what's common. So the final result would look like the shaded area in between is what I'm looking for on this. And what that means is every point inside of here, every point inside of between these two lines would actually work on this and would actually work on that at the same time. That's what that means. All right, so let's look at two more real quick. The red one is says y is greater than 3. So remember the y's are horizontal, and so this would literally be a dotted line at 3. And it says greater than that, so everything greater than that would be right above it. So every point above that. The blue, graph it like normal. So here's +1. And then up 1 over 1, up 1 over 1, up 1 over 1. And it's going to be a solid line. And it's everything less than that. And so now what you need to pay attention to, everything less than that is, everything lower than that line. So we're talking about everything on this side of the blue line. And again, notice the area that's double shaded. The double shaded area is this right here. And so again, what this section means is every point in this section, works on this and it works on this. That's what we're looking for. What section is common with all of those? And that's what you're trying to do. Again, and you could have 3 possible scenarios, or 4 or 5. Remember, we're trying to solve a system of equations. So here you have the x is less than 5, so you have a vertical line, and it's a dotted line. And everything less than that, so less than is to the left, so everything to the left. Okay, so it's going to be that way. And the red is y is greater than -2, so it's -2, and it's a dotted line at -2. And it's everything greater than that, so everything greater, which is above the red line. So far we have, look at the side, the area that's double shaded. That's what we're focusing on right now. And we haven't even graphed the green guy yet. So if you graph the green, notice you're going to start at +1. Whoops, green. You're going to start at +1. And you're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then that's a solid line. So you want to shade everything that's less than that solid line. So you're literally talking about over here. Everything on that side of the green line. So now you have to focus on what section is shaded by all 3 colors, because we got 3 colors going on. And so what's shaded on the inside is actually that triangle. And again, what that means is every point inside of this triangle will work on here, will work on here, and will work on there. That's what the triple shaded area means.